Well, thank you very much for having me here. It's a great honor to be at the Royal Society because, or to start off this lecture too at the Royal Society, because the Royal Society in the 18th century was very much involved in the transit projects. But let me start with an admission. So I'm going to talk to you, my book is called Chasing Venus, The Race to Measure the Heavens, but I don't really know anything about astronomy. I'm not an astronomer, I'm not an amateur astronomer, I don't even own a telescope. I have problems picking out a star constellation in the night sky. I can just about make out Venus at the moment because she's so bright. But my excuse is that I never set out to write a book about astronomy. And really, Chasing Venus is about much more than just astronomy. It is about astronomy with the subtitle, The Race to Measure the Heavens, of course, but it is also about kind of passion. It's about science. It's about adventure. It's about the foundation of modern science, and it's about the beginning of the global village in which we live today. Really, the book is about the first international scientific collaboration, and it's about hundreds of people who transcended national boundaries, religion, politics, and even war, all in their attempt to make sense of the natural world. And some people have asked me how I came to write this book, because it seems a bit of a leap from books like The Brother Gardeners, which was about the British obsession with gardens, and The Founding Gardeners, which was about the American founding fathers, to then write a book about astronomy. But to me, it all seems very logical, because when I worked on The Brother Gardeners, there's one chapter in The Brother Gardeners which is about Captain James Cook's Endeavour voyage. And I looked at it through the perspective of botany and plant collecting. But of course, I knew that the Endeavour had actually been sent to Tahiti purely for the reason to view the transit of Venus in 1769. And when I worked on my next book, The Founding Gardeners, I discovered that Benjamin Franklin, of course, had his fingers in the pie. He was actually masterminding quite a lot of the American effort to view the transit in 1769. So in a way, I had to kind of make that leap from the earthly pleasure to the heavenly delights. And as you can see from this here, these are all the book covers of the books which are coming out this week. The Japanese cover is missing. So writing this book has also become a truly international endeavor. So I'm very delighted to give my first talk about it here today. But let me first explain to you what a transit of Venus actually is. During a transit of Venus, the planet Venus moves across the burning face of the sun. So for around 6 hours, you can see Venus. Basically, Venus moves between Earth and Sun, and you see it as a black dot crossing the Sun. This is actually a picture from the transit of Venus in 2004. So forget solar or lunar eclipses. This year, the heavens have something much, much more exciting in store. The next transit of Venus will be this year on the 5th or the 6th of June, depending where you are. Here in Europe, it will be on the 6th of June. And we will be, if the skies are clear, we will be the last living people to see a transit of Venus, because the next transit of Venus will be in December 2117. I don't think any of us will be alive then. A transit of Venus is one of the rarest astronomical events. It happens in pairs, 8 years apart, and then it takes more than a century for them to return. And the first recorded transit of Venus was in 1639. And since then, we've only had 5 transits of Venus. And here are the dates, so one in 1761, one in 1769, 1874, 1882, and 2004. And I'm going to talk today about the 1761 and 1769 transit, because in the 18th century, which is what my book Chasing Venus is about, in the 18th century, astronomers believed that if they that Venus held the answer to one of the most pressing questions of science. They believed that Venus was the key to the size of the solar system. They believed that if they measured the exact time and duration of the transit, that they would have the data then to measure the distance between Earth and Sun, and that was by extension they could then calculate the size of the solar system. They were interested in these 4 times, which are basically the entry and the exit times of Venus across the Sun. They believed that they could use Venus as a natural astronomical instrument. It was almost like a celestial yardstick. The only problem was that they needed as many people as possible at as many different locations as possible to view the transit of Venus. Because what happens is that depending on your position on Earth in the northern and in the southern hemisphere, you will be able to see Venus crossing the Sun on a slightly different track. And as you can see here, that is how it would have looked like for the first transit in 1761. You can see that the observer in the northern hemisphere would see Venus entering the Sun slightly later and leaving the Sun slightly earlier, and therefore they would see her on a shorter track crossing the Sun. Now, then, with the help of relatively simple trigonometry, they could use the entry and exit times of Venus and the duration of the transit and the difference of the 2 tracks to then calculate the distance between Sun and Earth. But it would only work if they would combine their results. So no observation on its own would be useful. They would have to combine the viewings from the northern with the southern hemisphere. So something really extraordinary happened here. So in the midst of the 7 Years' War, hundreds of astronomers came together, despite the war, rallied together from all these different nations to, in the name of science, to view the transit. So they came together in the spirit of the Enlightenment, and the race to observe and measure the transit of Venus became a really pivotal moment of that era, an era where man tried to make sense of the natural world around him through rational thought. So expeditions were planned to all corners of the globe, to the Arctic Circle, Tahiti, India, Newfoundland, Siberia, and Baja California, amongst many others. This really was the most ambitious scientific project ever planned. And let's just think about it, what an extraordinary undertaking this is, because this is a time when clocks are not even accurate enough to determine longitude precisely, for example, where a letter from Philadelphia to London takes 2 to 3 months. So the sheer logistic and coordination of such a global project was just unbelievably difficult. So these astronomers had to travel to kind of the outposts of the known world. They had to travel through warring armies and hurricanes. They were laden with instruments which were weighing about, taken all together, because they had to take quadrants and telescopes and astronomical clocks, weighing about half a ton. Once they had arrived at their distant destinations, they then had to set up their observatories, they had to set up their instruments, and they had to determine their exact geographical position. And I'm just going to show you a couple of the instruments they're taking. So this is an astronomical clock. So it's huge. It's not like a little clock you take. And very annoyingly, they've just taken out the telescope from the library, because that was one of the telescopes that went on the expeditions in 1769. Now, the astronomers made also for rather strange adventurers. They were not really used to, dangerous explorations. They were much more used to the repetitive work of nightly sky watching in their observatories here in Greenwich or in Paris or in Stockholm. In fact, the job description of the assistant astronomer at the Royal Observatory in Greenwich is depressingly honest, because they were looking for men who were hardworking and, above all, obedient drudges. not exactly, I would say, characteristics you would normally associate with globe-trotting explorers. And at first sight, they might have not looked like heroic adventurers, and many of them were, in fact, well-fed and middle-aged men. I'm just going to give you a little collection here. So you have the French astronomer Jean-Baptiste Chappe-d'Auteroche, another Frenchman, Alexandre Guy Pingret. Admittedly, that bust is done when he's a little bit older than when he is when he goes to the expedition. And Neville Maskelyne, who later became the astronomer royal at the Greenwich Observatory. But as they chased Venus across the globe, they did so with unbelievable bravery and ingenuity. So let me tell you their story. In fact, let me start with one story of one astronomer whose experiences somehow really neatly summarize the obstacles, the tragedies, but also the kind of passion behind this endeavor. Let me introduce you to Guillaume Le Gentil, a French astronomer, and I don't have a portrait of him because there isn't one. He was a French astronomer, and he was the first in the race to chase Venus. He left France on the 26th of March, 1760, to travel to the French port of Pondicherry in India. And this is a map of some of the stops he made in the transit decades. You see he's kind of leaving in France, and then he's traveling kind of across the world. He and the other transit astronomers would be traveling at a time of the 7 Years' War, which had started in 1756 and which was tearing pretty much the whole of Europe apart, but also the colonial possessions in India, in Africa, and the Caribbean, and in North America. And as Le Gentil and many of the other transit astronomers very quickly discovered, that made for rather dangerous journeys. From the onset, Le Gentil's voyage was beset with problems. His ship was attacked by the British. Hurricanes tore the sails of his boat. His health was ruined by dysentery. And it didn't get better. At the end of May 1761, with only a couple of weeks left for the transit, which was on the 3rd of June 1761, and 14 months after he had left France, he finally saw the coast of India. Only just when he was thinking, yeah, fine, I have arrived, finally, he receives the devastating news that the British had taken the French port of Pondicherry and that he was not allowed to go ashore. So he saw the transit on a rolling ship, which made, he couldn't use his pendulum clock on a rolling ship. So he saw the transit, but his observations in a scientific sense were completely and utterly useless because he couldn't time the transit. Well, so his journey had been in vain, but nothing was going to ruffle the stoical Le Gentil. So he said, I missed the first transit. Well, there's another one in 8 years, in June 1769. There would be nothing that will prevent me to watch this. So he decided not to return home and decided to stay in the region for another 8 years. So he did some kind of, natural history collections around Madagascar. He stayed in Mauritius, that was his base. And then in 1766, 3 years before the transit, he set sail to Manila in the Philippines, where he wanted to observe the transit. He arrives there, plenty of time, builds his observatory, cleans his instruments, sets up his instrument, all ready. Then he receives a letter from the Academy of Sciences in Paris saying, what are you doing in Manila? You're meant to go to Pondicherry, which was after the end of the 7 Years' War, back in French hands. So off he goes, packs his bags, packs his instruments. A few months and a few storms later, he arrives in Pondicherry. And this is his route from Manila to Pondicherry. So he arrives in Pondicherry and builds an observatory on the ruined fort in Pondicherry. And this is a depiction of his observatory. And the observatory is the building to the right of the flagpole. So he is ready, basically. But strangely, I think, for a man who seemed to attract misfortune wherever he went, he built his observatory on a vault, which was also the arsenal for a staggering 60,000 pounds of gunpowder. Clearly, he didn't mind his explosive basement, and he waited for Venus. Then, in early June 1769, in the night before the transit, he was woken by a howling wind, after having seen clear skies for months. So until then, Le Gentil has always remained optimistic. However dreadful the situation was, he always found something nice about it. But even he now became depressed and wrote in his journal, "From that moment on, I felt doomed." You kind of wondered, quite a lot had to happen for him to feel doomed. "I threw myself on my bed without being able to close my eyes. At 6 o'clock in the morning, the sun rose behind a thick curtain of clouds. Le Gentil could see absolutely nothing of the second transit. And then, as if the heavens were mocking him, a few hours after the transit, the clouds disappeared and the sun burned into his face." So he had failed twice, and he began to prepare his long journey home. And I'm going to spare you the details, but needless to say, everything on that journey also goes wrong. So by the time he arrives in Paris in 1771, 11 years after he's left, he finds that his heirs have declared him dead and divided up his estate, and that he had lost his job at the Academy of Sciences. Pretty tragic, isn't it? So he was not the only one who was encountering problems. So everywhere across the globe, astronomers were going on these dangerous voyages in pursuit of Venus. And these expeditions were all organized by the scientific societies in Europe, including the Royal Society here in London, the French Academy of Sciences in Paris, and the Royal Academy of Sciences in Stockholm. There was, for example, Charles Mason and Jeremiah Dixon, later famed for the Mason and Dixon line. They were dispatched by the Royal Society to view the first transit in 1761 in Sumatra, in Bengkulu in Sumatra. They left in January 1761, only to see their ship attacked by the French within a few days, leaving 11 dead and dozens wounded. Traumatized by the battle, Mason and Dixon wrote to the Royal Society saying, "We don't want to go to Sumatra after all. This is a little bit dangerous, we think." But the Royal Society was not having any of that. So they were let us going back and forth. And the Royal Society ordered the disobedient astronomers to immediately continue their journey. Otherwise, they wrote, they would be punished as mutineers with the utmost severity of law. Fearing the legal might of the Royal Society, Mason and Dixon eventually obeyed and they continued their journey. But only partly, because in the end they stopped. They didn't go to Sumatra. They stopped at Cape Town. How was the Royal Society to know? And they took the transit observation there. And luckily for them, they were successful. And in fact, it was the only successful transit observation in the southern hemisphere for the first transit. And here is a depiction of Cape Town. The Royal Society also sent Neville Maskelyne, and they sent him to St. Helena. He traveled with the best instruments and also with 100 gallons of rum and wine in St. Helena, which was then still is one of the most remote places in one of the most remote islands in the world, basically in the middle of the South Atlantic. But at that time, it was a very important stopover on the British trade route. So Maskelyne was literally hitching a hike on an East India Company boat. So this is a map with the destinations of the British expedition. So originally planned in Bengkulu, but then it was in Cape Town and in St. Helena. For the astronomers, the transit observations promised scientific revelation, but they also knew that their measurements would improve navigation, which was very important for the trading empires and the naval powers. And in fact, that was something they could use to convince their governments and their monarchs to fund their expeditions, which is something that the French also did. And this is a map of the French expeditions in 1761. They organized Le Gentil's expedition to Pondicherry. They organized one to Rodriguez, which was an island very close to Mauritius in the Indian Ocean, and one to Tobolsk in Siberia. It was the French astronomer Jean-Baptiste Chappe d'Auteroche who went to Siberia. And his 4,000-mile journey from Paris to Siberia was also rather grueling. And his diary is full of references of accidents, describing how he and his carriage kind of crashed through frozen rivers, how they got stuck in deep snow holes and snow drifts, which I suppose is unsurprising considering the weight of the instruments. But Chappe was a rather cheerful man, and he found a lot of distraction in examining the women he met on the way. And he did so with the taxonomic precision of a scientist. So he compared, examined, and categorized them. He measured their petticoats. He remarked on their sparkling eyes, slenderness of their waist, better complexions, a very disagreeable figure, and well-shaped mates. And here is this is from Sharpsburg. According to him, this is how an interior of a Russian cottage looks, of course, including a half-naked woman. So the last part of his journey went across the frozen rivers in Siberia, and he traveled in these kind of sledges. So they're closed sledges which keep the cold out, basically. And there's a wonderful scene in his diary where he gets so excited about the speed they can travel with these sledges on the frozen rivers that he climbs out of the sledge and that he stands on the roof of the sledge with his kind of arms out, kind of to feel the wind and the excitement. Only then the ice began to melt and the whole thing became a race against the thaw. He made it just about 6 days after he arrives in Tobolsk. The ice breaks and melts, and the whole area is just flooded with this kind of big spring flood. So just when he thought he made it, everything's going to be fine, the whole expedition was jeopardized by the locals who tried to murder Chappe, because they thought that this strange foreigner who was pointing his telescopes towards the sky was a magician and had brought the floods upon them. But they didn't kill him. The governor of Tobolsk actually sent some soldiers to protect him. So by May 1761, the astronomers across the world were readying themselves for the transit. And most of the expedition astronomers had arrived, but they were not the only one who were preparing for the transit day. There were also all the astronomers who'd stayed in Europe. There were, for example, 30 official observers in Sweden, 40 in Germany, 30 in Britain, 40 in France, and 20 in Italy. Only the Americans were disappointed because the entire transit in America would happen in the darkness of the night. So they couldn't see anything. But one colonist, the Harvard professor John Winthrop, he traveled to Newfoundland, which was the easternmost tip of the North American continent, where he hoped that he would see the last minutes of the transit. So on 6th of June, 1761, the day of the transit had finally arrived. And as the Earth rotated and one location after another emerged from the shadow of the night into daylight, 250 astronomers looked into the sky at the same time. And I'm not going to tell you who succeeded and who not. You have to buy the book for that. It's just too much information, too many names. But even those who had a clear sky and who could see Venus on the sun despaired at what they were seeing. When the results were collected in the scientific centers after the transit, it became very quickly obvious that the observations were not as successful as they had hoped. The comments in the observations were peppered with comments like doubtful, not sure, not certain. So the problem actually was that Venus had not moved swiftly, quickly onto the disk of the sun, but had lingered for up to a minute at the edge. And you can see here how it looked like in 2004. So she was like seemingly glued to the edge of the sun, which made the timing of the transit completely impossible, because what was the moment actually Venus had entered the sun? And this is the so-called black drop effect. And here's another depiction of it from how it was seen in Uppsala in Sweden in 1761. If you look at figure 5 and 6, at the bottom here, you can see again the kind of like, the Venus kind of sticking almost to the edge of the sun. Others described that the edge of Venus was trembling, and others saw a halo-like ring around Venus. And this is a picture again from the 2004 transit, where you can see this kind of halo-like ring around Venus. So nothing about the transit seemed to be straightforward, and all the measurements and timings were just fraught with mistakes. So the astronomers went back and forth, but no matter how much they calculated, no matter how much they kind of pushed around with the numbers, and quite a lot of them did fiddle with the numbers a bit to make it all fit, their results varied widely. In fact, by more than 20 million miles. So this is the range in 1761 of the results. So this is the distance between Earth and Sun, and the range is so big that they have a difference of 20 million miles. Well, I say that was not bad, because in 1639, which was the previous transit before that, Jeremiah Horrocks had calculated the distance of the Earth just under 55 million miles. Today's value is just under 93 million miles. So the 1761 calculations were a great improvement to what Jeremiah Horrocks had calculated in the previous century, but the astronomers were rather unhappy with they like it precise, so it pretty much was a disaster for them, this result. But they had another chance, because there was the next transit in June 1769. They had 8 years to prepare, but they also knew that would be their last chance, because the next transit after that would only be in 1874. But the conditions for the second transit were much better than for the first transit. First of all, the astronomers now knew what they had to look out for. Secondly, the 7 Years' War had ended in 1763, so they wouldn't have to travel through warring armies anymore. And thirdly, the astronomic conditions for the second transit were much better, because the difference between the time of duration as seen from the southern and northern hemisphere was much greater for the second transit, which would make the calculations much more precise. It was decided that the Arctic Circle would be the best place in the northern hemisphere, and that the ideal counterpart for the Arctic Circle would be the South Pacific, which was a pretty empty and uncharted place on the 18th century map. But someone, it was decided, had to go there. And it was the Royal Society who organized the most daring voyage of the age. They formed a transit committee, which had Neville Maskelyne really in the lead. He was by then the Astronomer Royal. And they decided to apply for some money from King George III, because their own funds had been raided, because one of their clerks had actually embezzled £1,500. And there's a wonderful letter in which Benjamin Franklin explains, "While we have been attentive to what is to pass in the heavens, our clerk has unobserved run away with our money upon earth." So the king understood. He was actually the first British monarch who had a kind of formal education in science. So he gave £4,000 towards this expedition, and a ship was bought, and it was named the Endeavour, and it was put under command of Captain James Cook. On the 25th of October 1768, the Endeavour and her crew of 94 men set sail. They were packed to the brim with provisions, including 8,000 pounds of sauerkraut against scurvy and a rather overwhelming collection of telescopes, quadrants, and astronomical clocks. They even carried a portable observatory, which actually all the expeditions in 1769 had these portable observatories, which were designed by one of the an engineer who was also a fellow of the Royal Society. 3 months later, in November 1768, they arrived in Rio de Janeiro, where Cook wanted to fill their stores with fresh supplies, but they had problems because the Portuguese viceroy there thought they were either spies or merchants. He thought, and this is what he writes to Cook, "It's impossible that the King of England could be such a fool as to fit out a ship merely to observe the transit of Venus." He was convinced that they had an altogether different agenda, and he thought that this whole idea of the transit was totally absurd. In fact, he said it was so absurd as if the North Star would be passing through the South Pole. Despite these problems, Cook managed to kind of fill their stores, and they left, and they arrived on the 13th of April 1769 in Tahiti. And this is an engraving of the Endeavour anchoring at Tahiti. The crew enjoyed the island's women, but also had time to build a fort, which they named Fort Venus. And you can see the observatory is the round building in the middle with a flag on the roof. But not only the British were organizing expeditions, the Russians were also deeply involved, because Catherine the Great actually wanted to use the transit of Venus as an opportunity to prove to the international community of scientists and thinkers that Russia was not an uncultivated country populated with superstitious and alcoholic peasants, which most of the European scientists thought. So she was desperate to align Russia with Europe and the spirit of the Enlightenment. So she ordered the Imperial Academy of Sciences in St. Petersburg to organize 8 expeditions across her Russian empire. And this is a map showing the 8 expedition destinations. And she was really, she didn't just order this, she was totally involved in every single detail. She was constantly writing, she wanted to be constantly updated. She was advising on where they should go and also, what kind of observatories they should erect. So scientists across the world for the second transit were frantically busy organizing this. In Britain, Neville Maskelyne and the Royal Society not only organized the expedition to Tahiti, but also one to the Hudson Bay in North America and one to the North Cape at the northern tip of Norway. And the Danish king, Christian VII, asked the director of the observatory in Vienna, the Jesuit Maximilian Hell, who you can see here, to observe the transit in Bardo, which is a small island in the Barents Sea right at the top northern tip of Norway. And you can see here, actually in this drawing of Hell, in the background, he has a drawing put up on the wall, which is his observatory he built in Bardo. And this is a engraving of the observatory. And you can see it's exactly the same engraving. So the northern observations were incredibly important because they were the ones who counterbalanced or were the counterpart to the southern expeditions in the South Sea. And I'm just going to show you a few of the destinations here. The Swedes, for example, sent several expeditions to Lapland, with one particularly gloomy astronomer continually complaining about how ugly Lapp women are. The Endeavour crew was rather enjoying the women in Tahiti, all of them taking temporary wives. So while the Endeavour crew was just enjoying the kind of bucolic idyll in Tahiti, the astronomers in the north had a much harder time. There was, for example, William Wales who was the British astronomer who was sent to Hudson Bay. And he woke every morning during that winter before the transit with his bedding frozen against the headboard of his bed. And the actual headboard and his bed were covered every morning in like half an inch of ice. It was so cold up there that the brandy in his glass froze to solid ice within minutes. And he hated the cold. I mean, like, if you look at his diary, it's just this kind of relentless listing of the temperature. Like, he's totally obsessed with it. Because, ironically, the Royal Society had dispatched the one man who had stated in his interview that he was preferring a voyage to a warm climate. And then there was Sharpsburg again, who this time was not freezing, but he was having other problems. He observed the first transit in Siberia, and the second transit he wanted to observe in Baja California at the west coast of the North American continent, which was then in Spanish hands. And here is a map of, so he's going from France to Spain to Cadiz, and then he crosses over to Mexico, and then across Mexico, and then he catches a boat to go to Baja California. But his journey was riddled with problems. So first of all, he was stuck for more than 2 months in this kind of bureaucratic tug-of-war in Cadiz. Then he couldn't find a vessel. Then when he found a vessel, it was so small that everybody worried that he would not survive a winter crossing of the Atlantic. When he finally arrived in Veracruz at the Gulf of Mexico, he found himself in the midst of a hurricane and was very worried about his instruments, not just his life. And then he still had to cross the whole of Mexico to then catch his boat to then go to Baja California. When he finally arrived, it was the end of May 1769, and he only had a few days until the transit, which was on the 3rd of June. So he had to very quickly find a place there. So he set up his instruments in a typhus-ridden Jesuit mission, a decision that he would come to pay with his life. So he successfully observed the transit, but only hours after he noted down the essential data that they needed, he died. And here is a painting of his funeral at the mission. His watchmaker and painter, they took his observations and brought them back to Paris. So although he died, the observation kind of helped the calculations. Sharp was not the only observer on the American continent. There was William Wales in Hudson Bay, and this time the colonists along the East Coast were also frantically preparing, because this time the second transit would be visible in North America. And Benjamin Franklin, who was at that time in London, was masterminding quite a lot of the American effort. He was a member of the Council of the Royal Society and had been deeply involved in both transit, in both of the transits, in the 1761 and the 1769 one, in the preparations for the British expeditions. But he was also encouraging the colonists to do their bit, because he and his colleagues at the American Philosophical Society, which is basically the American equivalent to the Royal Society, they believed that the transit was an opportunity to prove once and for all, a bit like what Catherine the Great was doing, that America was not populated with backward-thinking farmers, but that they have good scientists. They thought it was important because the French in particular believed that everything in America was, as they said, degenerated, and that America had never produced a man of genius in any single art or any single science. So it was time, Franklin thought, to prove them wrong. So the American Philosophical Society planned several observations. One in the State House Yard in Philadelphia, where 7 years later the revolutionaries would declare independence. One in Delaware, and one in Norriton, which was just outside Philadelphia, and which was the farm of America's first astronomer, David Rittenhouse. But there were also problems. They needed to equip the observatory, for example, that the Americans were building. This is the observatory Rittenhouse building. They needed to equip it with instruments. So Franklin had ordered instruments from the London instrument makers to then ship them over to America. But the orders were all delayed because the instrument maker who was making the telescope, for example, had died. And it's quite likely, actually, that he had worked himself to death because the instrument makers in London were just working around the clock because they had so many orders from across the world. The other instruments that Franklin had ordered were also delayed. And he said, he wrote home that the craftsman had promised to deliver, but, and this is what he says, there was such a great and hasty demand on him from France and Russia and our society that possibly he might keep his word, but we are not to wonder if he does not. So he did, and the instruments arrived just in time in America. And in the end, there were 49 official observers in the on the American continent, not counting the many spectators that had assembled in the towns just to watch their astronomers seeing this celestial encounter. Around the world, there were 250 astronomers, official kind of observers, at around 130 locations. Britain was this time in the lead with 80 observers at 30 viewing stations in Britain and 16 abroad, not counting the North American colonies. Cook and his astronomer succeeded to view the transit in Tahiti. Sharp also did in Baja California, but he died afterwards. In the north, Maximilian Hell had the most successful observation in Vado. Catherine the Great stayed up all night and played cards so she wouldn't miss the most important event. And King George III watched from a specially built observatory in the Deer Park in Richmond and Kew. Le Gentil, as we've heard, only saw clouds in Pondicherry, while the American astronomer David Rittenhouse got so excited when Venus finally appeared that he fainted. And he managed to miss the beginning of the most important scientific event of his life. So at the same time, there were also lots of public viewings. So wherever astronomers set up their instruments, the kind of crowds assembled to watch them. And I'm just going to show you one example of a telescope which had like an apparatus kind of adapted to it, so you could actually project the transit of Venus on a wall, on a screen, so that more people could see it. And then there's also the Benjamin Martin's artificial transit, which is this is just an engraving of it, but he was a London instrument maker, and he built this huge artificial transit which had a hidden mechanism which moved the sun across the sky and also moved Venus across the sun. So he did this just in case it was cloudy. He could still entertain the kind of crowds in his shop because he was charging them for that. So astronomers remained glued to their instruments during the transit, no matter if there were clouds or rain, but their audiences quickly ran out of patience. Some looked for better entertainment. So, for example, when a thunderstorm obscured the sky in Leiden in the Netherlands, one spectator decided to see an earthly Venus in the opera house instead. And the observation there, he wrote to a friend, turned out to be successful, and the singer looked like she would have allowed some immersion. These earthly pleasures were also enjoyed by some young bloods in London who, as a newspaper reported, after having seen the black dot crossing the sun, made a transit into Covent Garden among a number of the said beautiful planets there. This was an area in the city which was known for its prostitutes. So after the transit, the astronomers once again shared and exchanged their results. And their letters, like invisible threads, connected them into this kind of global village. So there were these astronomers in Jakarta, in Madras, in St. Petersburg, and they kind of sent their results to the astronomers, say, in Göttingen in Germany, in Stockholm in London, Stockholm to London to Paris. So it was almost as if this avalanche of knowledge was rolling across the world. This time, the calculations were more precise. Astronomers still didn't agree about the exact number, but the margins were now narrowing, actually from 20 million miles to 4 million miles. So in in 1769, they calculated that the distance between Earth and Sun was between 93 million and 97 million, very close to today's value of just under 93 million. So pretty impressive, I think. But the most important result really was that for the first time, the international community of sciences had successfully and peacefully worked together. And the achievements of the transit projects really changed the world of science. And I think that is the really extraordinary thing about this story, is that so the byproducts of the expeditions were broad and wide-ranging. So, for example, maps improved because the astronomers all had to determine their exact geographical position. Many came back with much more than just astronomical data. They came back with trunks filled with seeds and pressed plants and stuffed animals, reports on soil and climate. So the idea of the kind of a modern scientific expedition was actually born at that moment. So from then on, every major exploration had a scientific team attached to them. Say, for example, Darwin's voyage on the Beagle, or even Napoleon's army in Egypt was accompanied by 200 scholars. So for the first time, governments had funded such global kind of big scientific project. And really they put a model in place which would remain there for the future. And never before, and we really have to remember that, never before had scientists kind of banded together on such a, international scale, really. So today we kind of take this international collaboration absolutely for granted. Yet we tend to talk about it as if it was invented in the 20th century. But in fact, the foundations lie very, very much and very firmly in the transit decade in the 1760s. So when we look up to the heavens, which I hope you will all do on the 6th of June, we really do so standing on the shoulders of these men who saw exactly that same spectacle 250 years ago. We don't have to risk our lives. We only have to protect our eyes, very important, and hope for clear skies. Thank you.